Hello everybody, my name is Łukasz Kujawa and I will be speaking today about test-driven development. Thank you very much for coming tonight, really appreciate your time. So before I will go into the presentation, I'll just tell you a few more words about myself. So my name is Łukasz Kujawa and I'm a developer. Are there no other developers with us today? Great, well done. First step is to admit it. All right, so I work at Glupal, where I lead development of e-commerce platform. So if you would like to learn more about that, you can visit glupal.co.uk. I have a blog at systemarchitect.net, and you can follow me at Łukasz Kujawa. Some people might find this account a little bit difficult to remember. I don't know why, but if you need it, it's on my blog as well. So, test-driven development. How many people are familiar with it? Oh, it's everybody. I don't have to say anything. Okay, so for those people who don't know, if you look for it on Google, you will find this nice definition which says test-driven development is a software development process that relies on the repetition of a very short development cycle. First, the developer writes an initially failing automated test case that defines a desired improvement or new function, then produces the minimum amount of code to pass that test, and finally refactors the new code to acceptable standards. I'm surprised they packed this whole definition in one sentence, but that's what it is. But what that really means in English. So the way I understand it is test before code, which might be a little bit strange to say because test is code as well. Nevertheless, this is how it's explained to my grandmother. So, yeah. TDD is an iterative process. You start on red with initially failing test, then you make some code to stop the test failing, which moves you to green, and then refactor. And then cycle repeats until job is done. So it's so-called red-green refactor mantra. Some people who come across this subject for the first time might feel that it's wrong way around, because how can you possibly test something which is not there yet? Although when you think about it, it might not be that different from traditional development, because let's just imagine you work on a new project, you create a little bit of code, you go to a web browser to see the output. Probably it will break because there is a typo somewhere or some other silly issue. So you go back to your code, you fix it. You go back to the web browser, now it works, great. So you go back again, you put some more code there. The thing is that you test it, you see the output after you've written the code, but you already knew in advance what you're going to do. You already had test in your head, it's just you execute it after coding. When with test-driven development, you just have to write it first. So, okay, so test before code. That works okay as a general definition, but to make it more specific, consider the 3 laws. So the first law is you might not write production code until you have written a failing unit test. The second one is you might not write more of a unit test than it's sufficient to fail and not compiling is failing. And the last one is you might not write more production code than is sufficient to pass the currently failing test. Sorry. Okay, so that gives much deeper understanding of what TDD is really about. It consists of small steps, the mantra. Does anybody remember the mantra?
Red, green, refactor.
Perfect. So yeah, red for failing, green for pass, and refactor for refactor. Right. So yeah, the small steps. You start on red. You write little bit of unit test, just enough to fail. You add some production code just to stop test failing. So you're on green. You add some more code. Some more test, some more code. Well, refactor is not here, but you refactor here, and that just goes on. If you remember the 3 laws, each of them introduce new keyword, unit testing. So what is unit testing? Again, on Wikipedia, there is this beautiful definition which says, in computer programming, unit testing is a method by which individual units of source code, sets of one or more computer program modules together with associated control data, usage, procedures and operating procedures, and tested to determine if they are fit to use. Simple. What does it mean in English? So the way I would explain it to my grandmother is testing smallest testable parts of application. Then she would probably ask what's an application, but it's a different story, I guess. Unit test is not a test. Now, this is quite important part, because it's quite easy to take unit test for something which it isn't. I think it happened to anybody who started with unit testing. It happened to me, and I know it happened to some other people. But there are some very strict rules which define what is unit test and what isn't. And the first rule is very narrow and well-defined scope. So you test just one particular thing in your system. No complex dependencies. That means if the code you're testing has some complex dependencies during the unit test, it means you test more than one thing, which contradicts the first point. Next one is test only one application layer. So if your code is during the unit test, talking to a database, to the file system, to an API, then what you're really testing is an integration. So you test integration, therefore it's not unit test, it's an integration test. And that's what happened to me. I was doing lots of unit testing, but I was really doing integration testing, so be aware of that. Environment independent. The whole idea of unit testing is being able to run it everywhere by everybody. So you have to be able to run it on all development machines, staging, production, demo, whatever you name it. You have to be able to run it everywhere. This is quite important, because if you can't do it, then you break the whole point of unit testing, because you just can't check is it working or not. And the last point is fast. This is just a practical reason. You want developers to run unit tests as often as it's possible. If it's slow, nobody's going to run it. Simple. And also, some IDEs, I don't know what's the name of that feature, can't recall it right now, but every time you save, it runs unit tests. So you can't use that. If every time you save your file, you have to wait 2 minutes, it just misses the point. All right, so at this point, some people might think, okay, it sounds a little bit difficult, a little bit strange, and you're right, it is difficult. It's not easy, and it's important to be aware of that. I'm not saying this to discourage you from using test-driven development, but to save your time, because my biggest problem was that I assume I understand it. I didn't do much research. The idea is simple, test before code, how difficult that can be. So if I knew in advance that is not easy, I'll probably go read a book first, do more research, and then get into it. So just be aware, it's not that simple. Now, it's not simple, lots of rules, confusing, what is there for me, what are benefits, and that depends, are you a developer or a stakeholder? So first I'll discuss benefits for developer. So first point is confidence. It just feels good when you know your code is stable, you do a good job, you're confident. So I think it's quite important. Code quality. Unit testing makes you a customer to your own code. So you have to prepare tests in advance. You have to think how you're going to use your own API, and also to make code testable, you need to, for instance, you have to be able to inject dependencies. That on its own make the code flexible, and thanks to that, thanks to this additional flexibility, you can easier extend it, do something else than you initially plan to do with it. Time. So test-driven development should save time in the long run. It can also save some time during development, especially web development, because when you, let's say you create an application in PHP, and usually, well, traditional approach would be write some code, switch back to the web browser, write some more code, switch back to the web browser. And every time you want to see your output, you need to replicate user journey to see the output. And that takes some time. And even if it's just refreshing page, I personally still find it distracting. You might accidentally switch to a messenger or to something else. You lose your attention quite easily. So I prefer, if I can, I'd rather stay in IDE and just do my work there. And as I said, lots of IDEs allow you to integrate it with unit testing framework, so you don't have to go anywhere. You create your business logic. You don't even have to take your hand off of a keyboard and do something with mouse. You can have a shortcut or something. So it's quite nice to work that way. Refactoring. Unit testing helps with refactoring because you have much more willing to refactor. It's not scary. So if you work with big system like Glupal, where I work, you might get afraid of touching something which already works because it might break. You rather not touch it when it's working, and that's not a good approach because with the time, with this attitude, without refactoring, well, this will contribute to code quality degradation, and eventually you might find it difficult to work with that software. So it's good to refactor, and unit testing definitely, and test-driven development in general, definitely helps with that. Reopening issues. That point is often raised by quite popular developers. They say that's the mature way of fixing bugs. So when you have a bug, you first create a unit test which fails, and then you fix your code for that unit test. So the next time somebody tries to reopen this bug by accident, then he will instantly have a feedback you've done something wrong. So we avoid reopening the same issues. And again, it might sound funny, how can I reopen my own bugs? It is possible, and I've been in this situation when you have lots of issues in a pipeline, like 50, 70 tickets to close. You don't really think about what you're doing, you just jump next, and you might work along with some other developers, and you can just reopening each other issues. So that helps avoiding that. The last point is self-documenting code. Some people see unit tests as an example how to use certain parts of the system. So if you don't like documenting your code, you might just have those examples. Now, benefits for business are much easier. Money, whole pile of money. First point is shorten development cycles. You want to save time with TDD. That's the whole idea. That's the reason why you do it. So if your development cycle is shortened, then obviously it costs business less because they have to pay for less resources. That takes us to the second point called deliver more. Now you have those few more days. You can just create more features. You can maybe work on some other projects. So just earn more money, really. And the last point is stable products. Unit testing, test-driven development helps a lot with making sure you release stable products, which contributes to your better relationship with your clients and belief in your brand, which also ultimately brings you more money. Okay. Hello. That's fine, no worries. So, right now I just gave you a promise. TDD will do this for you, TDD will do that, but what are the facts? There were some attempts to research efficiency of test-driven development through empirical research. Now, before I will discuss the data, I'd just like to point out it's quite difficult to perform reliable research, generally speaking. And here, when it comes down to measuring quantities like team technical knowledge, project size, even time taken to develop, because it's not that straightforward, really. It's very difficult to get accurate measurements. Nevertheless, there were a few people who tried their best to measure that. So the first research I found was performed by Roy Ashroff in his book, Art of Unit Testing. The book is mostly about creating good unit tests. I think the context is C#, but it doesn't really matter. But not only. He discussed about a few other interesting things. One of the page, unfortunately, literally just one page, is about tests he performed in one of the companies he contracted for. And what he compared was two different teams. One was using test-driven development, the other one wasn't. They were working, according to him, on a similar size project. Both teams had similar technical knowledge and capabilities. So his finding was that implementation took twice as much time in a team which was doing unit testing. So twice as much time here. Although from this point, integration, testing, bug fixing looked much better. So team without test stayed behind. And at the end of development, of the whole process, team which was using unit testing was 2 days ahead. What I personally find really interesting is what happened after that. So when the code got released into the production, it turned out that bugs found in the code created by team without testing, well, there was 7 times more bugs, which I think it proves that test-driven development really helps to reduce those numbers, especially at the point when you really don't want to have it when you release. Second research is much more verbose. In fact, it has 300 pages, and it was created by 4 people. One of them was a professor, 2 of them were PhDs, and one of them was a development manager. So they knew what they're doing. It's quite difficult link to remember, which will take you to that research, but if you just Google for studies of test-driven development, you'll get there. And those people were measuring amount of bugs in four different projects in 2 different companies. So one was IBM, the other one was Microsoft. IBM team was working on drivers, Microsoft team was working on Windows, MSN, and VS. What they found was that when team was using test-driven development, the amount of defects in their code was less by 40 to 90%, and the additional time required to work in that way was between 15 and 35%. So that was finding of this study. I think that proves if you use TDD, then you will definitely have less bugs in your code. So let's assume you like what you've heard so far, you'd like to give it a try. How to start unit testing. So I guess the simplest way would be just create an empty file, bootstrap your application, instantiate a class you want to test, do some assertion, That's fine, so long you follow the mantra, the laws, all theory behind that. It's a valid approach. You can do it that way. Obviously, it's not the best way to do it. You can always do better, so you can go for a framework. There are many unit testing many frameworks for unit testing available for PHP as for any other languages. I listed only 2, the most popular one for PHP, but there are at least 4 more. The one I'm using in Glupal is PHP Unit. The other one I'm aware is pretty popular. It's called Simple Test. So what are benefits of using framework for unit testing? I guess it's similar with any other framework. So you don't have to maintain it, you don't have to create it, you don't really have to worry about that. It's there, and it also gives a structure to your work. So it just shows you the way you have to do. They give you guidelines. So it gives you API, no maintenance. As I said, it integrates with most of the popular IDEs, so that's quite helpful. Frameworks can, maybe not every, but definitely PHP Unit can generate you coverage report, which is quite nice to have, and support mock objects. Does anybody know what mock objects are?
They're objects, your collaborators, which you inject into your class that you're testing, so you can make assertions on that you're calling the right methods with the right parameters.
Cool. Do you know what's the difference between mock and stub?
Yeah, a mock is the object, kind of a stub. So you pass in a fully complete mock that potentially you didn't write. But if you're writing 2 classes, you haven't finished writing the second one, you might pass in a stub of that class. So it allows you to work on one thing at a time, and then you understand how the 2 classes kind of relate.
Yeah, good. That was a little bit tricky question, to be honest, because different people might say different things, and even different frameworks might tell you different things. So in some system, it means exactly the same. Mocks are stubs, and that's the end of the story. In book, The Art of Unit Testing, the author draws a line between stubs and mocks, but they are pretty similar. So, as Rob said, stub is just a fake object which mimics some other object. And for example, like if you want to unit test a configuration parser, that configuration parser could use another class called configuration provider, which would provide to the parser raw configuration from somewhere like database or file system or any other place. And for your test, you don't really want to go into database. In your unit test, you don't want to go into database. You don't want to go into file system. So what you would do, you would create a fake config provider, just make it to return one fixed configuration, which in that context is called stub, and just inject it into the configuration parser, and that's how you test it to have a proper unit testing approach. Well, mock is a little bit more than that, so it also decides what is the result of the test. So you say that mock should be called twice, or it should be called with this attribute, and at the end, or actually during the test, it will throw some errors if that's not happening. There's this nice diagram which just summarizes what we just said. So stub just communicate with a class on the test, and unit test is doing the assertions, while with mock is doing the assertion. Of course, you can also have some assertion in unit test, but they can also come from here. Yeah, so this is an example of very tiny unit tests created with PHP Unit. So you have a static method, just set up your application. There is a protected function which run before each of those tests. So it set up your environment. In this case, just instantiate a class, and you test something else, do some assertions. So this is an example of how it looks. This is an example of how Eclipse integrates with PHP unit. So it doesn't look much different here, but you can bind running unit tests to some combination of keys, and below you have the output. So as I said, you don't have to go to a web browser, just press some keys, see it below. Okay, there are a few things people usually realize after they decide to start unit testing, and that's sometimes blockers. So it's quite good to be aware of that before you start unit testing. First thing is, you can't test directly. You can't test directly private, protected, and static methods. It won't work. So the idea behind it is you don't test it directly, but you should test it through through public methods, which should go to those private or static ones. So it's an indirect testing always, and you should never change visibility of those methods for sake of unit testing, because that's breaking rules as well. Tests only functionality. So yeah, that's the whole idea. You test only functionality, it doesn't test integration. You might have 100% code coverage, everything works, but you release to production and breaks because it doesn't integrate. So something to be aware of. You can't test code which talks to the database directly, which is usually the biggest problem for people. And there are lots of different ways to mitigate that, although there is no one simple formula which says this is the way to do it, it will solve all your problems. No, it's actually quite problematic. And yeah, as everything requires discipline, so you just need to be motivated to do it. Oh, yeah. That's out of alignment, but yeah, should try it. Yes, definitely. You should try it. Give it a go just for one project. You might like it, you might not, but definitely worth trying. So red, green, refactor. Questions?
Yeah, I know that at Google you're using it for Zend at the moment.
Yeah.
Zend 1.
Yeah.
What sort of challenges did you have in terms of integrating and using it with Zend?
Well, Zend provides you some classes you extend for unit testing. So it gives you a little bit of support, although I think that would be the same problem as with any other framework. You try to unit test something which is often deeply tied with other part of the system, and like to get something, to get autoloader, for instance, you have to bootstrap something. So you start adding complexity on your test, which is not the best way to do it. So I think this is the bigger problem, and of course database.
Yeah.
But I think this is everywhere. You have the same issue.
How close do you go to like Vue? So if you've got a controller,
Mhm.
sort of, I guess in Zend it would probably render a view or something like that.
Yeah.
How close do your unit tests go to that, covering that kind of logic?
Yes, so that depends how you use your views. We use lots of view helpers. We also use Zend has this whole engine for generating forms, and there's lots of forms in our system. So those forms has elements which has own logic as well, so we can unit test those components. So we don't directly unit test views, but we can test forms. There's lots of logic in forms. There's some logic in elements of those forms. So this is how we do it.
Yeah, how easy is it to kind of retrofit this stuff, let's say, where you've inherited a legacy system and you want to start to apply kind of test-driven approach?
That's a very good.
Where would you start?
That is a very good question, and how easy or not easy it is, that really I think comes down to how motivated you are to do it. Though, if you read about test-driven development, unit testing, you will find many opinions that if you work with legacy code, many developers say they can imagine working with legacy code, refactoring legacy code without unit testing.
Yeah.
So they actually turn the table around. They say, we just can't work different ways. So it takes more time, but for us, that's the only way to do it. Yet I can imagine it might be quite tricky.
So you'd need to write a load of tests to take a baseline starting point before you started to refactor.
Yes and no. That depends how you can break your logic.
True.
Like, you can find one class which has few thousand lines, and you see that out of it you can make 20 or 30 classes, and that might be quite big, big piece of work. But saying that, it's proven that, again, lots of opinions. People say that usually 80% of problems are in 20% of code. So that is the best place to start. And it's lots of effort you have to put into it, but it's only 20% of code.
Okay, thanks.
More questions? No? Okay, thank you. Thank you very much.